Okay, let's talk about how to find the zero of a quadratic function. So previously we talked about solving quadratic equations. This is actually very similar. So let's remember again, what does it mean to find the zero of any function? It really means that your y value is 0 and you're trying to find your x value or values, depending on the function that you're given. And so again, this is really setting the function equal to 0 and solving for that x value, okay? And so that's what we're going to do here. We're turning this into a quadratic equation. This is going to be 6x squared plus 7x minus 5 equals 0. Okay, so we're going to set it equal to 0. We're going to find basically when f of x equals 0, the solutions to that, and those solutions will be the zeros of the function, the x value when the y value is 0. All right, so this is going to be the same process as solving a quadratic equation, and we're doing this by factoring, so we're going to factor our left-hand side. That means we've got 3 terms that we need to turn into 4 terms. So we're adding our blanks here in the middle and bringing down the 6x squared and the negative 5, and also bringing down the equal 0. Next, a times c. So our a in this problem is going to be 6, and our c in this problem is a negative 5. So our a times c is going to be 6 times negative 5, which is negative 30. So we want to know what multiplies to negative 30 and adds to b. B in this problem is 7. Okay, so let's create our list of all possible pairs that multiply to 30. 1 times 30. 30 divided by 2 is 15. 30 divided by 3 is 10. 30 divided by 4 does not work out evenly. 30 divided by 5 is 6. And then we end up getting 6 times 5, which is a repeat, so we're stopping there. So we want to know the combination that adds to 7. Adds to 7. Now, here's the thing. Again, we're adding, but these could be positive or negative. It just depends. So let's figure that out. If this is negative, then the signs are different. Signs are different. So we're going to have one positive, one negative for our factors. And then if this is positive, that's our b. If our b is positive, our b is going to our bigger number, our bigger factor. So just looking at that, we know our signs are different. So we know we need the difference between these numbers. So 1 and 30 is not going to work. 2 and 15 won't work because that's going to give you 13. And then 3 and 10 is going to give us that 7 that we need. But let's consider the signs. So again, our bigger number gets the sign of b. Our b is positive, so our bigger number 10 gets the positive, and we know our signs are different, so this needs the negative. And again, if you're not quite sure, just do the double check. The double check is, does it multiply to negative 30 and add to 7? And in this case, it does. Now we're taking these, putting it back over into the problem in the blank. So negative 3x plus 10x. And now we can group. So we're grouping our first 2 and grouping our last 2. Now we're factoring out the GCF in each group. So looking at our first group, we have 6 and 3. Always start with a smaller number and see if it goes into the bigger. 3 does divide evenly into 6. And so this is going to be 3. And again, x always comes out there because it's in common. So we're dividing by 3x to simplify. And that's going to give us 2x minus 3 divided by 3 is 1. In our second group, we've got 10x minus 5. Okay, so we've got 5 that goes into 10. So 5 is going to be part of our GCF. And no x here. So it's just going to be 5. And that's what we're dividing both of these by. Simplifying gives us 2x minus 1. 5 divided by 5 is 1. And then we're going to our final factored form here. So again, taking our GCFs to make 3x plus 5. And our common parentheses here of 2x minus 1. And then finishing this out gives us 3x plus 5, setting each one of these equal to 0. So equal 0. And then 2x minus 1 equals 0. Solve both of these. So minus 5, 3x equals -5, divide by 3. And we get x equals -5/3. Here we've got +1, 2x equals 1, divide by 2, and x equals 1/2. So our solutions to f of x equals 0 are our zeros. So these are our zeros to the function f of x equals blah, 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 blah. Okay? And again, to kind of connect the dots here, this is saying if my x is -5/3 and I plug that in, the -5/3, then you're going to get 0 out. That's what this is saying. If I take 1/2 and I plug it into the function or substitute it in, evaluate the function, you're going to get 0 out. Okay. Now, would I sit there and do that? Probably not, but that is one good way to check if you wanted to. All right. So that is finding the 0 of a quadratic function, and that's actually finding the 0 of any function because, again, finding the 0 is setting it equal to 0 and solving, and that's what we did here.